Bismillahirrahmanirrahim. Hyperconjugation in organic chemistry. In this lecture, I will teach you super easy tricks to learn hyperconjugation in organic chemistry. I will also teach exam questions. So, watch this lecture till the end and you will learn something awesome. Firstly, I will teach you the concept of sigma electrons and pi electrons. Without learning of some of these basic concepts, you will not be learn hyperconjugation. Now consider the organic compound. We know that in double bond there is some sigma bond and pi bond. Some pi bond and one sigma bond is present. In pi bond there exist pi electrons, while in sigma bond there is sigma electrons present. Now the single bond between carbon and hydrogen is also known as sigma bond, which contain sigma electrons. Thus remember that pi bond contain pi electrons and sigma bond contains sigma electrons. The second important concept which you must learn is alpha carbon and alpha hydrogen. We define alpha carbon as the first carbon atom attached to a functional group. For example, consider this organic compound. Here functional group is alkane. This is the first carbon attached to the functional group, hence it is alpha carbon. These three hydrogens are linked to the alpha carbon, and these are three hydrogens. Secondly, consider this organic compound. We can see that this is a functional group of alkane. On the right hand side, this is the first carbon attached to the functional group. It is alpha carbon, and in these three hydrogens are alpha hydrogens, while on left side is also considered as alpha carbon attached to the functional group are called alpha carbon, and these three hydrogens are alpha hydrogen. In this molecule 6 hydrogen present. Thirdly, consider this organic compound which is carbocation and first carbon attached to it, and hence it is alpha carbon. These are total 3 hydrogens and in this molecule. Lastly, consider this organic compound. Pause the video and figure out alpha carbon and hydrogen in it. Well, this is CH2 and this is also CH2. These both carbons are alpha carbons and alpha hydrogens at the left hand side and right hand side. Hence, there are 4 hydrogen present in the compounds. Now, what is hyperconjugation? Hyperconjugation effect, we need alpha hydrogen and sigma electrons. Let me repeat it. We need alpha hydrogens and sigma electrons. For example, consider this organic compound. Here, remember this important trick. In case of carbocations, positive sign show vacant orbitals of carbon. Hence, this is positive sign on this carbon shows that orbitals of this carbon is empty. I rewrite carbocation like this. We can see that p orbitals of this carbon is empty. Now listen carefully. Here there is a sigma electrons on carbon and hydrogen bond. Secondly, this hydrogen is alpha hydrogen, and hence both the conditions sigma electrons and alpha hydrogens are satisfied. So hyperconjugation is possible here. Now there is a possibility that these sigma electrons of hydrogen shift to empty orbitals. We get a new structure like this. This hyperconjugation, and this hydrogen has given its electrons to carbon. Its bond is broken and we write it here. Remember that when sigma electrons shift, bond is broken while positive charge on p orbitals disappear because it has gained one electron here. Secondly, there is also possibility that these sigma electrons of this hydrogen will shift to this empty orbitals. We get another possible structure. Thirdly, there is also possibility that these sigma electrons of this hydrogen will shift these anti-orbitals, we gave third possible structure. Therefore, we defined hyperconjugation is the shifting of sigma electrons to adjacent half-filled or NTP orbitals to increase the stability is called hyperconjugation effect. Let me repeat it. Hyperconjugation is shifting of sigma electrons to adjacent half orbitals or NTP orbitals to increase the stability. This is called hyperconjugation effect. Let me repeat it. Hyperconjugation is hypothetical and it doesn't occur in real life. Also noted that these three resonance structure of this carbocation. Thus, we learned that when sigma electrons shift to NTP orbitals, this effect is known as hyperconjugation effect and it increases the stability of a compound. Now, I will teach you some important questions. Why hyperconjugation is also known as no bond resonance? Well, it is because there is no bond between carbon and hydrogen atoms. For example, consider this carbocation hyperconjugation effect is occur. We can see that hydrogen has given its sigma electrons to the p orbitals. There is no bond between carbon and hydrogen. Therefore, we say that hyperconjugation is also known as no bond resonance. Secondly, why hyperconjugation is known as sigma pi resonance? Well, it is because sigma electrons are shifted to the vacant orbital or pi orbitals. For example, consider this carbocation. We can see that the sigma electrons of this hydrogen is shifted to the NTP orbitals of the carbon. Due to shifting of sigma electrons, resonance occur. Therefore, we say that hyperconjugation is known as sigma pi resonance. Thus, noted down all these important questions. Now, let me teach the importance of hyperconjugation. Well, hyperconjugation help us to determine the stability of compound. I mean, the more our alpha hydrogen is more, hyperconjugation more, and the more stability. For example, this carbocation which is more stable, we can see that this is alpha carbon and this is alpha carbon and this is also alpha carbon. Each alpha carbon has 3 alpha hydrogen, hence there are 9 alpha hydrogens. Here there are 6 alpha hydrogen and therefore there are 3 alpha hydrogen in this carbocation. Number of alpha hydrogen and even hyperconjugation wouldn't occur here. Accordingly to this rule, the more alpha hydrogen, the more hyperconjugation, the more stability. This hyperconjugation has more alpha hydrogen, it is more stable compound. This compound has no alpha hydrogen, so it is least stable compound. So it is least stable compound, hence this is the order of stability. Therefore, need to study the hyperconjugation in order to determine the stability of organic compound. Now let me teach one most important concept in which the following hyperconjugation is possible. Well, consider hyperconjugation. Consider this calf. Hyperconjugation only occur in carbocation, alkane and free radical of hydrocarbons. Now first compound is aldehyde. Hyperconjugation is not possible in it. The second compound is carbocation. Hyperconjugation is possible. The third compound is alcohol. Hyperconjugation is not possible. And the fourth compound is alkane. Hyperconjugation is possible. Fifth compound is free radical. Hyperconjugation is possible. Thus, remember that hyperconjugation is only possible in calf. Finally, let me teach super trick exams questions. Well, remember that no bond resonance structure is equal to number of alpha hydrogen. For example, consider these some organic compounds. Find the number of no resonance bond structure. Well, in the first phase, this is alpha carbon and this is also alpha carbon. and 3 alpha hydrogens and 3 alpha hydrogens. Here are total 6 alpha hydrogens, hence there are total 6 no bond resonance structure possible. Secondly, this is only alpha carbon. This alpha carbon has only one hydrogen, hence one no bond resonance structure possible. Thirdly, this is alpha carbon. This is also alpha carbon, and this is also alpha carbon which is linked to this carbon. Hence there are total 6 alpha hydrogen. Hence there are 6 no bond resonance structure possible. So some exam important questions: no bond resonance structure, no alpha hydrogens. These three structures are given to this, and this is assignment for you. And thanks for watching us. Goodbye and Allah Hafiz.